So let's move on to the next question. Consider a particle of mass m that is attached to the two identical springs. So there's a two identical springs and a mass m is attached, and the length of each spring is L, and this spring constant is K. That's given in the question. And this is the equilibrium configuration of the unstructured springs, and there is no external force that is acting on the system. That is the equilibrium configuration. And if a particle is given a small displacement, if we are given a displacement in x-axis, which of the describes the equation of motion of the small oscillation is the question. So the spring is structured to the x-axis, so there will be change in the length of the spring. Of course, the change in length, originally it has a length of L, now the length will be root of L square plus S square. And what will be this change in length? The change in length is equal to the change in new length minus the original length will be the delta x, will be the structural length is equal to root of L square plus S square, and the original length is minus L. So we need to find the potential of the two springs. First we calculate the potential of one spring and then multiply it with the 2. We will get the potential of the two springs. So half of K the change in x square, and we are taking out L square outside. What will be happen? 1 plus S square divided by L square minus of L, and taking the L out of the root, L square out of the root, there will be L, and these two L's are taking out, there will be L square outside. Okay, the root of 1 plus S square, L square minus 1. So what will be 1 plus S square divided by L square whole raised to 1 by 2. So there is an equation 1 plus nx plus n into n minus 1 divided by 2 factorial of this term, square of this term. So 1 plus root of 1 by 2. So n will be 1 by 2 of S square divided by L square plus this n into n minus 1 will be get this answer, and omitting these terms and taking the square of these terms will be obtained s raised to 4L raised to 4. So this will be the thing, and multiplying it with the 2 for the two springs we will obtain this 2 get cancelled on the denominator and numerator. So will be obtain K of s raised to 4 divided by 4L square. So the L will be, the Lagrangian will be the kinetic minus the potential. So the kinetic energy will be half of m s dot square, and the potential energy will be this, and taking the Euler Lagrange equation will be obtain this, and simplifying will be obtain this as the final answer.